Hello friends, this video on chemical bonding part 3 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched part 1 to part 2. So let's start our chapter with the first approach we have, that is the Lewis approach of chemical bonding. Let's understand the Lewis approach for the chemical bonding. So as I told, chemical bonding is something which exists in nature and there are various theories to explain this chemical bonding. The first approach was the Lewis approach. So what this guy did was he assumed that the nucleus plus the inner electrons as one kernel. Please note, the nucleus plus inner electrons were one kernels, and the outer shell electrons, it says that it could accommodate at the max 8 electrons. Please note that this is not true for all case in real life. But this is just a theory to explain, and this explains most of the chemical bonding. Because we have scenarios where this theory is proved to be wrong. This theory says that the nucleus plus inner electron is kernel. If you see, these are the kernels, and it can accumulate at the max 8 electrons, the outer shell. So if you see, the lithium, for example, has only one outermost electron. Lithium has only one electron. Sodium also, if you see, has only one outermost electron. Why? Because sodium configuration, if you see, it is 281. Correct? So in case of sodium, these electrons are my inner electron. The outermost electron is only one. So what we are saying is that the kernel is both my nucleus and the inner electron. So in case of both sodium and lithium, the outermost electron is 1. Correct? So beryllium, if you see, has 2 outermost electron. Magnesium also has 2 outermost electron. So the kernel in this case of magnesium is the magnesium nucleus plus the inner electrons. Thus, if you see, the lithium and sodium look same. Beryllium, magnesium look same. Boron, aluminum looks same in the Lewis approach. Carbon, silicon also looks same, though they have different number of electrons, but the outer number of electrons for both carbon and silicon is same. Right? Because this guy is saying that, this theory says that the nucleus plus the inner electron is one kernel, and the one in the purple is my kernel. This is my kernel. Right? These are my kernels. So the outermost electrons is something which matters the most for this approach. Please note, only the outermost electrons matters for this approach, and that's why there is no difference in beryllium and magnesium, or boron and aluminum, or carbon and silicon, or nitrogen and phosphorus. Similarly, oxygen and sulfur, there is no difference as far as this Lewis approach is concerned, because both have same number of outer electrons. So if you see neon and argon, they have same number of outer electrons, and this says that this can have at the max 8 electrons, outermost electrons. So if you see, argon has 8 outermost electrons and neon has 8 outermost electrons. This is the max they have the outermost electron. This is what this theory says. Correct? And then he also further assumed that these 8 electrons occupy the corner of a cube. That's why if you see, I made a cubical structure. These occupy the corner of the cube. This is what this theory says. This theory proposed that this occupies, but actually it is not. If you see the quantum model, we see that these electrons keep jumping here and there, right? There is no fixed cube or cuboid kind of shape where these electrons are. But this theory proposed that just to understand the chemical bonding, let's assume that this is the scenario. It's all assumption. Please note, all assumption. Correct? And he also proposed the octet of electron, that is 8 electrons in the outermost shell. Outermost shell. So octet of outermost shell electrons, you can say, and this represents stable electronic configuration. This is what it was proposed by this Lewis approach. Why? Because he told that all the noble gas, neon, argon and all, they have 8 electrons in the outermost shell and they are stable. And so he assumed that if you have 8 electrons in the outermost shell, you attain a stable electronic configuration. Again, please note, just a proposal. Right? And he also proposed that, in fact, he postulated that these atoms, they achieve stable octet when they are linked by chemical bond. Example, if you see these case, this guy A has 7 electrons in the outermost shell, B has also 7 electrons in the outermost shell. When they combine, the electron is shared. These I'll make it blue or red, the one which is shared. These electrons are shared, right? They are shared actually. So this is a shared electron. There is no electron here, sorry. Yeah. So it is shared, and both these let's suppose atom 1 and this atom 2, atom 1, atom 2, atom 1, atom 2. So both these atom 1 and 2 thinks that it has 8 electrons, and both these feels that they have got this stable configuration by sharing, right? And that's how they form the chemical bond. This is again Lewis postulation. This is what a way to understand the chemical bond. This may not be correct actually, but this is a way to understand this chemical bond, and it actually helps us to understand the chemical bond a little easier. We'll explain the better type of approach to understand the chemical bond. This is a very basic approach to a chemical bond, and this actually helps us have a fair idea of chemical bonding, right? So please let me repeat this once again. He assumed that there is something called kernel, which has my nucleus plus inner electrons, and the outer shell electrons can have minimum 1 and maximum 8 electrons, right? And he assumed that this kernel is surrounded by is in a cube-like structure, and these 8 edges of the cube occupy these outermost electrons. And each and every atom, they want to attain this stable configuration. When I say stable configuration, he means octet electrons in the outermost shell, and this they can achieve by sharing of electrons in the chemical bond. And this is one example they have. He showed was there are 2 atoms 1 and 2. They both combined. Both had 7 electrons each in the outermost shell, and they combined to form this kind of molecule. This is a molecule now, right? So this is 2 atoms. They form a molecule, and this molecule, both these atoms have 8 electrons. Correct? So they both have shared these 2 electrons are shared. So to achieve the stable state, he proposed that there can be a covalent bond, that is by sharing of electrons, or an ionic bond, that's by transfer of electron. For example, I explained this covalent. For example, chlorine, if you see, it has 7 electrons in the outermost shell, right? 7 electrons. And you know that chlorine exists in Cl2 molecule form. So what this guy does is, there's one more chlorine molecule which also has 7 electrons. So a pairing happens between these 2 electrons, right? So this chlorine assumes that it has 8 electrons, and this chlorine also assumes that it has 8 electrons. If you see that, right? So both assumes it has 8. For example, if you see this chlorine 1, it has 7 plus 1, 8 electrons. This chlorine has 7 plus 1, 8 electrons. So both assume that they have 8 electrons and they form a bond. This kind of bond is called covalent bond, when there is a sharing of electron. For a transfer of electron, I can take example of sodium chloride. Sodium chloride also, if you see, exists in NaCl form. Generally, sodium doesn't exist in Na or Cl form independently. They exist in NaCl form. Why? Because sodium has 1 extra electron and chlorine has 7 electrons in the outermost shell. So for sodium to achieve electronic stability, if it can lose 1 electron, it can achieve the stable configuration. Because the moment it loses the 1 electron, the next shell which it has, the sodium, if you see, is atomic number 11, 281 is electronic configuration. If it loses 1 electron here, it will reach the octet rule according to the Lewis approach. So it will become stable. So it will lose 1 electron. It will give 1 electron to this guy, and it will develop a positive charge. And since chlorine will get 1 electron, it will get a negative charge. So it will be sodium ion and chlorine ion, right? Because the moment it gains one electron, it will get a negative charge and it will be 8 electrons now. Now since there's a positive charge here and negative charge here, they'll attract each other and they'll form a bond. This kind of bond is called ionic bond, where you actually transfer the electron. In this first case, we share the electron because nobody is willing to give electron. Chlorine has 7, it just want one extra electron to be stable, so it won't give up. So nobody is willing to give up, so they'll share. So in this case of sodium chloride, sodium is willing to give one electron to achieve stability because it will attain a more stable configuration. Chlorine is ready to take electron to achieve stability. So it's a mutual benefit if the sodium transfers one electron to chlorine, and that happens. And so sodium chlorine is formed. So there are two different kind of bonds, covalent and ionic, and this is explained by the Lewis approach. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.